Hello and welcome to another episode of Python Beyond Basics, and today we are doing sets in Python, which will be super nostalgic because of the amazing high school mathematics, right? Okay, you ready? Let's get into it. Okay, so sets are basically unordered and mutable data structure which does not allow duplicates. Okay, right now we have just saw the data structure which allowed duplicates. Obviously we were not allowed to have duplicate keys in dictionaries, but they allowed duplicate values, right? But here we cannot have duplicates. Okay, let's see how will that look. So let's say my int, we have to give a pair of curly braces like in dictionary, but actually if we try to let's do this 1 2 3 4 5, and let's give 4 again and 3 again. Okay, and let's print my int. Let's see how does that look. Okay, so Python, what's this, fourth day I guess. Yeah. Okay, so 3 and 4, even though we inserted twice, but it came only once, so it does not allow duplicates. Okay, so now let's check type of sorry, type of this. Okay, this should be set, obviously. Yeah, class set. Now if we delete all these elements, how would that look? Okay, this is a dictionary, right? So keep that in mind. Empty curly braces are not empty set. So empty set would be like this. I guess it would be like that. Yeah, class set, and that's empty. And later on, since it is mutable, we can add elements to it, like my int dot add 1 2 3 and so on. Okay, not type of, okay, my bad. Okay, yeah, 1 2 3. Now we can even create set from various iterables like lists. Okay, like 1 2 3 4 5 6 7 8 9 10. Okay, awesome. Now yeah, we get the set. Okay, and we can even create set from an integer. Hello, let's try that, and it is hello. Now see, the what do you say, here you can see one L is missing, obviously because it does not allow duplicates, and the string is inverted, and it can be in any order since that is unordered. Okay, so we cannot index elements to get it. Okay, so that you have to keep in mind. So I already told you that we can add elements to it using dot add, right? Let's say 4. We'll see, it should allow different data structure, different data types as well. So yeah, and we can remove elements like this. Wait, not like this. Dot remove. Yeah, dot remove should remove h from that. Yeah, it does. But one thing, that if an element is not present in here, like 5, and if I yeah, string 5, and if I try to remove that, it will give me a key error, right? So one thing you can do, that you can use discard. Okay, and what this will do, even if it's not present, it won't remove that and it won't throw error, but if it is present, it will remove that. Okay, and obviously no error, right? So to suppress that error, you can use discard instead of remove. Okay, hope that's clear. And obviously you can clear your set using my dot clear, and this should remove everything from your set. Okay, empty set. Awesome. Now using pop method will give out what do you say, item, arbitrary item, because it's unordered, so it will give out arbitrary item. Okay, and I don't know if this returns. Let's see. Yeah, it does return. It will remove an arbitrary item. Okay, now it's removed 4. Now it removed again 4, again 4, again 4, again 4. Oh, okay, I don't know, because we have less choice, maybe that's why. Anyways, so it will remove an arbitrary item and return it as well and remove it from the set. Okay, that's pop. And obviously, like all of the data structure, we can use in operator to check if something is inside that. Like for I in my int, we can iterate over it, print I, and this should print everything in the set, right? And obviously we can use if else as well. If h in my int, I don't know why is that my int, print yes, right? And obviously we can add an else clause as well, like we have been doing this complete series. By the way, this is a series, this is a part of series Python Beyond Basics. If you haven't watched other videos, you can click that I button to check other videos. And yeah, okay, now comes the fun part, the high school mathematics I was talking about. Okay, so there are a couple of methods which we can use on sets, different sets. Let's say we have odds. Okay, we have set of odds, we have set of evens, and we have set of, let's say, odd, not odds, and we have set of prime. Okay, now let's keep everything below 10. Okay, so for odd it will be 1, 3, then 5, then 7, then 9. Okay, and for even we'll have 2, 4, 6, 8. Okay, and for prime we will have 2, 3, 5, 7. Okay, awesome. Now if you remember your high school maths, okay, you will see, yeah, so you will know some of the methods like union. What union will do, union will combine every set. So union will combine sets, like if I do something like odd dot union and even, they should give us every element q. Okay, so let's save that in u and let's print that u, and this will give every element. Okay, all right, so I have pulled up a Venn diagram which I think will help us to understand the concept of sets. So here, this thing, these blue plus green will give the union for those two sets, and in this case odd and even, which will give all of the elements that are present in both of the set, not common in both but all of them present in both. Okay, let's say if I do with prime, okay, this should give us 1, 2, because it's here, 3, 4, 3, 7, 5, and then 9. It's not in prime but it's in odd, so it will be in the resulting set. Okay, now if I do intersection, intersection is basically common in both, right? So if I do union even, this should be, wait, I'm still printing, yes, and I'm still doing union intersection. Okay, and it will be an empty set because there's no common item between odd or even. But if I do prime, and this will give us 3, 5, 7, because here it's 1 and that's not prime, right? And 9 also. And if I do with even, we'll just get 2 because that's the only prime, right? Very, very cool. Now we have difference. Okay, and by the name of it, you should understand that that will give us the elements present in the first set but not in the second, right? So difference even will give the items present in the first set. Okay, these are disjoint, my bad. I mean, nothing in common. So yeah, this will give the items present in odd but not in prime. Okay, I hope that makes sense. Basically the difference of two sets, right? By the way, this was the intersection of two sets, okay, present in both. Okay, and this thing is the difference, like only blue. Okay, only blue, not none of the green in that. Okay, I hope that's fine. Okay, now there's symmetric difference. Symmetric difference, what's that? Let's check. Okay, symmetric difference is basically removing the common thing. Okay, I mean, this will remove everything common. Okay, but it will present the items of other set as well, and in the difference it was removing everything from that and only containing the elements of that. Okay, but here it will contain two as well because it's removing only the common thing and then keeping it, taking the union of that. Okay, now we have update. Now you everything we did right now does not update any of the sets, right? But now what we'll do, we'll update the set. Okay, so let's say that's why we were saving it in a new variable. So if I do odd dot update, this will be basically taking the union and saving it to odd, right? Updating the odd. Okay, so now odd become this, but even will be that only, I guess. Even will be, yeah, even still only 4 items. Anyways, so update will be the union for updating, and it will change the existing set. Then we have intersection update. Intersection update, this will basically contain empty set, obviously, because these are disjoint, right? And this is basically the intersection, but adding update will update the odd. Okay, last time we stored it in I variable, but this time it will update the odd set, right? And that's why we are just adding update here. There's difference update, which will do the same thing as difference but update the set, odd set. Okay, 1 9 odd is updated. And there's symmetric difference, and that will update the odd set. Okay, awesome. Now we have some things like checking for is subset of. Okay, so subset is basically meaning, okay, let's do this. Like we have natural numbers which start from 1 2 3 4 5 6 7 8 9. Okay, and we have whole which starts from 0, then 1 2 3 4 5 6 7 8 9. Now you will see that this natural number is a subset of whole number because it contains every element that is there in whole number, but whole number is superset because it contains more, but everything that is in the natural number. I hope the name is clear, but we'll just try to do something like natural dot is subset of whole. Okay, is it a subset of whole number? And it should print true, right? Because that is a subset. But in case I add here 10 or 20, okay, that was also fine. That is not a subset because it contains something which is not in this. Okay, so that's not a subset. So let's make it a subset again, and let's try superset. Okay, is superset. Okay, so it's not obviously superset, but if we do something other way around, whole natural. So this would give us true because natural is a subset of whole number. That's why whole number is a superset of natural number. That should be clear, I guess. Okay, awesome. Now we have disjoint, which we have been seeing all the way along here, right? Like odd and even are disjoint. Why? Because they don't have any, you know, element in common, so that's why they are disjoint. But on the other hand, is odd and prime disjoint? No, because they contain something. So if two sets are disjoint, their intersection would be a null set or zero set or empty set. Okay, and my audio is again, wow, my camera, okay. Anyways, let's see one thing that we have been seeing all along, and that is copying a set. Okay, let's say odd 1 equals odd. Now if you have been watching my videos, okay, which we did in the last, you would notice that we have covered copying in every data structure, right? And same way in this, if we change odd 1, let's say add 1000, so that we get this, odd will also be updated because that's not exactly a different copy. Okay, so to copy it, to make a different copy, we can simply say dot copy. Okay, and this will and changing the copy one will not affect the original one. Okay, and otherwise this thing was just, you know, pointing to a same object in the memory. I have been telling this since last 4 videos, so I guess that would make sense now. In other way, if you want to do, we can simply pass a set to you know, set function. We can pass the older set and make a copy of it, and this will also create a new copy, and it affecting or mutating it won't affect the original set. I hope that's fine. Now there's one thing, that's frozen set. Okay, what we'll do, we'll try to froze okay, so we have a frozen set here, and if the frozen set is something that which we cannot, you know, what do you say, change it, mutate it. Okay, so a frozen set has no attribute add. Okay, so frozen set is something which has everything a set has, that it won't allow any duplicates and all, but we won't be able to, you know, change its value. We won't be able to mutate it. I hope that's clear. And with that, we come to the end of this video, and I hope you liked it. If you liked it, please hit that thumbs up and subscribe to the channel, and share the video because I need it. Okay, and bye bye, I'll see you next time. And tomorrow we might be doing linked list. We will start data structure because a lot of inbuilt data structure we have covered, so I thought we'll start with linked list, and I'll see you there. And obviously click here to subscribe and click here to watch more videos so that you enjoy. Bye.